You have probably seen this curve quite a few times, but what is so special about it? This curve is known as the normal distribution. A normal distribution has many characteristics that make it important in statistics. Firstly, its mean, median, and mode are all the same value. This makes it easy to explain the distribution. Secondly, the total area under the curve is 100%. It is easy to know how many standard deviations from the mean a value is. Around 68.2% of the data lies within one standard deviation from the mean, around 95.5% of the data lies within two standard deviations from the mean, and around 99.7% of the data lies within three standard deviations from the mean. Clearly, the normal distribution has many statistical benefits, but what if a distribution is not normal? Say you have a large population of different birds with different wingspans. You are trying to determine the distribution of wingspans. However, since the population is extremely large, instead of taking the entire population of birds, you take small groups of 5 birds at a time and take the mean wingspan of each group. After repeating this process a few times, the distribution looks like this. Yikes, not very normal, but repeating it a couple more times gives this distribution, which looks pretty normal. Next, what if the sample size was increased to 10 birds, 15 birds? As the sample size increases, the distribution becomes more normal. This phenomenon is known as the central limit theorem, which states that as the sample size increases, the distribution of the sample means will approach a normal distribution. The central limit theorem allows us to statistically describe a population without taking data from the entire population. It has been used for many statistical purposes and will undoubtedly continue to facilitate future discovery.